Hi, Brashan. So we want to make a cosine wave that has these like specific properties. So right off the bat, if there's a little Chrome pop-up that's blocking my face, I apologize. That's a glitch that's happening at Wyzant to everybody. And I've tried and there's nothing I can do about it. So here's my face. Here it is. You're like I said, it's just a glitch and it's not my fault and it should be fine. Okay. Okay. So to tweak a cosine wave, or a sine wave, this works the same way. We just need a couple of things. So this multiplying a number on the outside of the function is going to mess with the, in this case, the amplitude. In general, this is called a vertical stretch. So if you multiply a function by any constant, it's going to stretch it vertically. Okay. If you multiply a constant in here, it's going to stretch it horizontally. And in the very specific case of trig waves, cosines and sines, it stretches it in this way. The period is going to be 2 pi over this number. And that's just something you just kind of have to memorize or remember. So another way to write that, which is more useful to us here, is that b, this number we throw in there, is going to be 2 pi over the period. And that's just because normal trig waves have a period of 2 pi. You know that. So to tweak it, you put this number inside it and it stretches it, but it stretches it in a way that you already like, based on the fact that the natural period of it would be 2 pi. And then to move it, so you said in your question to have a midline of 5. I think I understand what that means. That's called a horizontal shift, or in the case of trig waves, a phase shift. Fancy, right? So that's going to shift it horizontally. Sorry, this is getting a little messy. Okay, so to do what we said, here's what we want. And the nice thing about this is you can just, once you do it, you can graph it on your calculator and just verify that it looks right, and we'll do that. So we want the amplitude to be 2. So that's the simplest part. You just multiply a cosine wave by 2. And like I said, that's called a vertical stretch. It just takes the wave that normally has an amplitude of 1, stretches it out by 2. That's the simplest one to kind of wrap your head around. Okay, so we want it to be a cosine wave. Now, b is 2 pi over the period we want. We want a period of pi, so that's a pretty simple calculation. But again, it's just one of those things you just kind of have to memorize that. So b is 2 pi over the period, and the period is 2 pi over p. So if it were the other way around and was asking you to graph something that was given, you'd say, okay, the period of this thing is 2 pi over whatever this number is. Since we want to make it, we have to say, okay, this number is 2 pi over the period we want. So that's just 2. So you throw a 2 in there. And then for the horizontal shifts are a little weird because when you subtract a number in there, it's actually going to go to the right. So are you mirrored from me? That's the right. Yes. It's actually going to go to the right. If you add a number, it's going to go to the left. And again, it would actually, in this case, work out the same either way, but it doesn't matter because if you want a midline of 5, then you just throw a -5 in there. Okay, so that's your horizontal shift, or again, in this case, a phase shift. Now, let's, there's a way to check. I assume you can use a calculator on your test coming up, so here you go. Let's graph that thing. Here's a calculator. I just typed in, well, I ignore this other stuff. It's from my other classes. 2 times cosine of 2 times x minus 5. Okay, and when you go to the graph, that should look exactly right. So there's your cosine wave. It has an amplitude of 2, right? That's the amplitude is top to bottom. It has a period. Now, the period of pi is kind of hard to see. I'll switch that in a second. Notice 1, 2, 3, 4, 5 is now the midline, right? So it's been shifted over to kind of start at 5. If I do, maybe you've seen this, do a Z trig or a trig zoom, what that does is it changes these little hash marks on the x-axis to be in terms of pi's instead of in terms of just 1. So if you look like from here to here, again, since we shifted it, it's kind of hard to see, but these are pi over 2s. So these hash marks are pi over 2s. So you get the sense that from this peak to this peak, it is about pi. Right, it's 2 of those hash marks. It goes from there to there. So that's the one that's kind of hard to see exactly because, well, it just depends on how you have it zoomed. If you go back to a standard zoom, maybe you know that pi is like 3.14. So if you look from this peak to this peak, it's like 1, 2, 3.14. So I guess you kind of have to take my word for that one. Okay, so I would encourage you to use your calculator to check those. There's absolutely no reason not to, right? And then you can just look at it and see that, oh yeah, it looks right. So it's 2 cosine of 2 times x minus 4. Okay, thank you.